Well, hello all. Have you ever considered that you may be a scientist and that I may be a scientist? According to one definition of science, a scientist is someone who practices the scientific method, has a hypothesis, carries out an experiment with dependent and independent variables, records his results, does some research. Well, all of us can do that. You may think, but you don't look like a scientist. Well, maybe if I put on a lab coat, will this make me look more like a scientist? And maybe no. Does a lab coat a scientist make? I think not. So we're going to be a scientist according to that definition. Now, another definition is that you're an expert in your scientific field. Well, the field that I want to investigate is mulches. And I think by the time I've finished these scientific experiments, I will be an expert in the field of mulches. So why mulches? Now, I like gardening. I'm a poor gardener. And the reason I'm a poor gardener is I'm a good scientist, I think. I like experimenting in the garden. And, experiments have a tendency to fail. For example, my latest crop of tomatoes are planted in leaves, and they don't like growing in leaves because their roots get alternately wet and dry, so the poor tomatoes haven't done too well. But I just love experimenting with growing crops in different media. So let's get to the subject of mulches. A mulch is a layer of something that you put on top of the soil to keep it, I am hoping, the same temperature, keep it moist, add to the structure of the soil. But generally, this experiment is just to see how a mulch keeps the soil from getting too hot. And plants don't like warm roots because it spoils the uptake of nutrients. It dries out the soil, it causes stress on the plants, and the soil can get very dried out and degraded. Mulch can add to the nutrients too. So there's a million types of mulches. I'm thinking for my experiments of trying, the first thing I'm going to try is coffee grains. Later I'm going to try tea leaves and sawdust, eggshells. We can use bark. We could use seeds. What else have I got? And there's a million and one other things, like you could try paper, you could try sticks, you could try stones, anything. So bearing in mind that there's an infinite amount of mulches, here's my hypothesis. I'm going to say that every single mulch will help to keep the soil cooler. Now, I'm thinking some mulches, like coffee grains, will be darker. They will therefore absorb more sunlight, get warmer, but I still think that the coffee grains will keep the soil shaded and therefore keep the soil cooler than just bare soil. So the scientific method means you must have an experiment and a control, and both must be identical except for one factor that you're changing, and that is the mulch. So in my experiment, I'm going to have a mulch, and in my control, I'm going to have the same soil without a mulch. And then I'm going to see if the one with a mulch stays cooler. And I say my hypothesis is that no matter what the mulch is, the mulched soil will stay cooler and wetter, but I've got no way to test the dampness of the soil. So let's just stick with temperature. So what have I got? I've got a Pi Pico attached to a computer, and the Pico is running two thermometers, these 18B21 line thermometers, one in the experiment box, which is a fish liver plastic container, and one in an identical container. So there's two of these thermometers, and they're going to every 10 minutes read the temperature and record it over a period of hours through the day. And we're expecting to see the graph of the one without a mulch to go up and the one with the mulch to stay at a lower temperature. And then we're going to repeat that for multiple different types of mulches. We could do this over a couple of weeks. And just think how easy that is, folks. How easy it would be and how useful. Imagine in this world of global warming, if you can simply add something to cover the soil. It could reduce your water bill. It could help, with global warming, extreme temperatures, keep the temperature of the soil less extreme so your plants don't dry out and suffer stress. So I think it's an enormously important thing. And what have I spent? I've spent $4 on a Pi Pico, about $4 on two 18B20 sensors. That's $8. I'm sure where you live it might be even cheaper. So that's all it's cost me. I have a little bit of coding experience. Everyone's talking about coding experience, that it's a way to solve the job crisis. Well, I think it's wonderful to know a bit of coding. I think you can learn coding very, very quickly. So you could become a scientist and an experimenter and a coder. You don't have to be able to write perfect code. You just have to download examples of the code and know enough coding, like I do, to be able to change the code to suit your particular needs. And that's what I've done. And I've written a piece of unique code that reads the two sensors and records the results every 10 minutes, stores it on flash memory of the Pi Pico, and after 3 or 4 hours in the sun, we're going to put it on a windowsill so there's no wind. We want to keep every condition the same. And, if there's wind, it might affect the mulch differently to the soil, but all we want is the sunlight to be the factor. So our independent variable is going to be the mulch. The dependent variable is going to be the temperature. We're going to compare the temperatures for both our experiment, which is the one with the mulch, and the control, the one without. So there we have our experiment. I will show you in a moment how I plan to set it up. I'm going to get two identical amounts of soil, just enough mulch to cover the one, start recording the temperatures, leave it for a few hours, and then download the data. So here is our computer. Here is our Pi Pico connected to computer. Here are the wires to the thermometers. I'm going to take some sand. So here is the sand, and I'm going to scrape this knife across the top. I push the sand down. I'm going to scrape it across the top and get just one equivalent. I need to use equivalent amounts of sand. So if we take this knife and pull it across, we know that in each case, experiment and control, we're going to get the same amount of sand. So there is one lot of sand, and we're going to put that. Now, what have I got here? I've got a bowl with 4 layers of insulating cardboard in these fish liver containers. And I'm going to make sure that all the sand goes in there. And then I'm going to tamp this down. And there is, it says 16, it's the control. That's the one without mulch. And it's covering the thermometer. We're going to get this as level as possible. And now we repeat and do the same thing for our experiment. So we're taking quite a dark mulch, which is our coffee, and we're just going to put enough coffee on. Now I know we're adding something here, and you could say, well, that's not quite the same, but we're just adding enough mulch, these coffee grains, to cover and shade the soil. But it's, bear in mind, the coffee is darker, and dark attracts the heat or absorbs the heat. So now our experiment has got a darker covering over the lighter soil. Maybe it will make it hotter. So we cover all parts of it. I'm putting the thinnest layer of mulch possible. And now all that's left is to put it on the windowsill facing the sun. And there we have our experiment and our control. Look at the difference in the color, otherwise everything is identical. And now we're going to read the temperatures of both. Hopefully they're both the same. And then every 10 minutes we are going to read both experiment and control, experiment, and see how the temperatures begin to diverge once they're in the sun. So we've moved our computer and all, here go the wires up to our windowsill. There's our experiment and control. You can see our control is getting a little bit of sun, so is the experiment. We put two things on either side so it doesn't get warmed from anything except the top. There it is, and we're going to leave it for the day or for a few hours to record the temperatures, and that would make us a scientist. You could easily do the same. Just find some little experiment that one can perform. And this, I'm sure, would be useful to many people with pot plants on windowsills who all drink coffee, have got coffee grains. Let's see what effect coffee grains have on our experiment. And there's our control to have something to compare it with. Our program automatically records the temperature from the real-time clock, but it's now just on 9:10 in the morning, a.m. Should record that. Should take a reading every 10 minutes. So 9:10, let's see if the first reading looks around about that time. So here is my Thonny Pi program. I don't want to go necessarily through it line by line, but I tell the program to read the temperature every 10 minutes and to write the temperatures of both the one with the mulch and the one without the mulch onto a file called temps9.txt. So we had 8 prior ones that were just trials, and then the temperatures 9.txt is where we write the actual data. And if you look at the end, we told it to sleep 600 seconds, which is 10 minutes between taking the values and writing them. So let's go to temp 9.6, and this is what we got it to spit out over a period of about 7 hours. So here on pin 16 was our control, the one without mulch, and here's the one with mulch. So mulch, no mulch, mulch, no mulch. It writes the date, which is the 27th of the 8th, 2023. The time, 10:09 and 55 seconds. And then it writes the temperature, 11.3125 degrees centigrade. And it does this. That was for the experiment control. So we had to extract, and I will change these temperatures. And what I did was I took all the temperatures and I put them onto a graph. Let's just see if I can pull out the graph. There was the graph. So what I found, the blue is with a mulch. Actually, so here's the mulch values, and here's without a mulch. And what I found, the blue line here is the mulch values. And I got docs.google.com spreadsheets to print the to do the graph for me, so I don't have to do the heavy lifting here. And actually, this difference between the two is about 2 degrees. and you can see for the first whole lot of readings, this was 10 readings, which is over an hour. They were more or less the same. There's 6 readings per hour. So this is a graph over 7 hours, and you can see that the one with a mulch actually had a higher temperature, which was completely against my expectations. So now I'm becoming a scientist in the other definition of the word. I'm learning, I'm becoming a specialist on mulches, and I've found that certain mulches raise the temperature of the soil by 2 degrees. Then look at the time. This I looked about 33 readings later. This is just at about 3 p.m., so 3 hours past noon. The temperature starts to drop off again. So the temperature reaches its maximum at about 2.5 hours past midday. And then slowly in the late afternoon at about 3 o'clock, it starts to drop again. This was a completely sunny day. So look what I've discovered, that a dark mulch is worse than no mulch. It actually raises, excuse me, the temperature of the soil. So the soil without a mulch actually had a lower temperature. Well, now I'm becoming an expert because it just shows that a mulch need not necessarily help. So so what I just did was I put all the readings 1 to 41. There were 41 readings. I put the ones with a mulch in one column, the ones with no mulch in a column, and then all one has to do is highlight all the readings, and then go insert chart, and it inserts this chart. And here it's just made a second copy of the chart with a mulch and no mulch. So let's just move this graph out of the way. It's as simple as that to draw graphs on a Google spreadsheet. You just highlight all the values and get it, and just insert a graph of the 3 columns that you've highlighted, and it'll take. This is your x-axis, the one horizontal axis, and these 2 are your y-axis, and this goes north 10 degrees centigrade, 20 degrees centigrade, 30 degrees, 40 degrees, and you can see that that is about 2 degrees centigrade difference. So how lovely, we've learned so much. Now my new hypothesis as an expert is going to be, I bet if I take white eggshells and use them as a mulch, they will reduce the soil temperature, they will reflect light more than the beige sea sand or river sand soil. So I've already learned a lot from this experiment, and that is that the color of the mulch seems to matter, which is kind of, I suppose, obvious. And I also learned that the temperature goes up for the 3 hours after midday. So I've learned a lot that I didn't know. So I am a scientist. I'm applying scientific methods, using scientific equipment. I've got my experiment and my control. I've got my hypothesis. I've got my independent variables, which is the time, which is the 10 minutes between each reading. I've got my dependent variables, which is the temperature of each of the 2, the experiment and the control. There's the experiment, the one with a mulch and the one without our control. So we've done good science, and I can now call myself and add that to my portfolio. I am a scientist now, and I'm becoming an even better scientist in the sense I'm now becoming a little bit of an expert. I'm a much greater expert on mulches than I started out the day with. My knowledge has increased, and now if I try all different kinds of mulches, different colors, I'm sure that I'm going to learn even so much more. And what did it take me? A few dollars worth of equipment, bit of programming. Let's just go back to Thonny. Here was my program. I call it 18b20.py. And I don't, as I say, want to go through the code, but I did just borrow code from all over the place and then just tweaked it and modified it. And it's quite complex, and I don't want to waste, if you call it a waste, time on this code, but I'm going to see if I can copy this code and put it into the description so that anyone who would like to see the code and use it can do so. And I think what I should also do is show you a chart of, draw a circuit diagram of the actual how I connected up all the sensors. So I think I'll do that as well. So let's see if we can copy and paste all this small amount of code into the description as well. I'm not sure how long a description YouTube allows. And also then take a picture of our circuit. Let's draw a circuit diagram and show you how we connected it all up. Here then is a wiring diagram. We've got our Pi Pico, and on the right of it here's pins 0 to 15, 16 to 30. Not the last, second last, the third one from the end is the ground, and that goes to a pin of your 18V20. Then the 3.3 volts goes to another pin, the positive pin of both temperature sensors. And then you've got from pin 16 and 17, it goes to the one wire pin that's going to actually measure the data of this, and we have to have a 4.7 kilo ohm resistor between, it's a pull-up resistor between the 3.3 volts and the data pin. So I'm using two resistors, and it's like two separate systems. I know there are better ways of doing this with these one wire things. You can connect them both to the same pin, but I've put them to two separate pins, just made it easier, I thought, for me to program. So there is the circuit diagram that I used.